This is a continuation of the solutions for Algebra A, Test 2, Quarter 4, and the next problem is going to ask us to solve each quadratic equation. So we got a couple different methods we've used in the past. Quadratic formula, completing the square, and factoring. And I always go with factoring if they don't mention for me to solve a certain way. It's always easier, unless the factoring is obviously very difficult. But factoring only works for answers that are rational, so we have to be careful on that. Well, I can see the numbers that multiply to make 36, subtracting to make 5. It would be a 9 and a 4. Had to be opposite signs because they multiply to make a negative, but they add to make a positive. And so now I use that zero product property, which says I'm going to take the two factors, x plus 9, set that equal to 0, and I set that x minus 4 equal to 0 as well. And so I can go ahead and do some opposite operations now. Subtract the 9 from all sides, and add the 4 to all sides as well. And so what we have is an x equals negative 9. Over on this side, we have x equals 4. So there it is, negative 9, positive 4. These are the two x-intercepts. Notice it's not an ordered pair. It's where the two lines end up crossing, or actually where the parabola ends up crossing the x-axis. These are the values of x when y equals 0. Well, this next one looks like a tough one. Now, some people might want to use quadratic formula for this, but I always go with factoring if I can. You see, numbers that multiply to make 12 would be like a 3x and a 4x, 2x, 6x, 1x, 12x. But notice that they're opposite sides. The outside-inside terms need to subtract to make an 11x. And what that tells me, it's just a guess, I think it's going to be 3x and 4x. And the reason is that the numbers can't be too far apart. The 3 times a number and 4 times a number needed to give me something where the difference is 11. So I think it's going to be a 5 and a 3. And again, this is just kind of a guess. I just think it's going to be this because, you see, this makes 20x and this makes 9x, and those will subtract to make 11x. So I know it works now. Now, in order to make it a positive 11, I need to have more positives than negatives. So I'll put the plus sign with the 5 and the minus sign with the 3 there. Now I've figured out the factored form. I take the factors and set them equal to 0. 3x plus 5 equals 0, and 4x minus 3 equals 0. So when I go ahead and solve, I'm using opposite operations here. I'm subtracting 5 from all sides. So I can now have this 3x equals negative 5. Divide by 3, and we get our answer, negative 5/3. That's one of the answers. The next one, we have to add 3 to all sides. I get this 4x equals 3. Divide by 4. I get the other answer, 3/4. So these are the two x-intercepts, the values of x when y equals 0. It's not an ordered pair, it's two x-intercepts. Over here, we factor, and it factors to two binomials again, x minus 1 and an x plus 4. Now, why plus 4? Well, because the numbers have to subtract to make a positive. I need more positives than negatives. So I'm using that zero product property again, setting the two factors equal to 0 to come up with the two values that make the parabola, or where the parabola ends up touching the x-axis. And it touches at positive 1. And take the 4 away from all sides, it also touches at negative 4. So those are the two x-intercepts, 1 and negative 4. Well, looking at this one, another solve the quadratic. And so it's a positive 2, so that's the prime number. I'm going to start with 2. Typically, I always start with the x term, but since it's a 2, I'll start with the prime number of 2 and 1. Now, outside-inside terms need to add to make 9. So I'm going to try 3x and 3x. And both have to be plus signs because they multiply to make a positive and add to make a positive. And so always check the answer, see if it works. So this makes 3x, this makes 6x, and those two will add to make the 9x, which is what we have right here. So once you have that, take those factors and set them equal to 0. 3x plus 2 equals 0, and 3x plus 1 equals 0. So I go ahead and do some work there. Opposite operations here. So I'm subtracting the 2 from all sides. So I got this 3x equals negative 2. Divide by 3. And we got that one answer of negative 2/3. Over here, you got to subtract the 1 from all sides. So 3x equals negative 1. Then I can divide by the 3. and I end up with x equals negative 1/3. So those are the two x-intercepts, negative 2/3 and negative 1/3. The values of x when y is 0. Here they're asking us to complete the square for the expression and factor the perfect square trinomial. So let's see what we get here. So x squared minus 8x. What do we have to add to both sides? Well, take this negative 8 and divide it by 2. Take half of it. It makes negative 4. Take that negative 4 and square it, and that gives you 16. So that's the number that you'd have to add to both sides. How does it factor? Well, it factors to whatever half the b term is, and this time negative 4. So x minus 4 quantity squared. So what's your answer? 16, and the factored form as well. Over here, figure out what half the b term is, and that just makes 2. So we have a negative 2, but then you take that negative 2 and you square it, and that gives you 4. So that's the number that gets added to both sides. And then how does that factor? Well, x minus 2 quantity squared. So those are the answers they're looking for. Now check out part 3 for the last few problems from the study guide.